Woo, it worked.
Yay.
Good morning, everybody. Hey, welcome to IHIF's Business Development Forum, current webinar featuring Kay Townsend with BSA LifeStructures. We're excited to bring this program to you today. During our last webinar, a lot of folks had said they could really use a primer on just where the different types of space that we talk about when we're talking about life sciences companies and understanding what's out there, what the clients are going to need, what they're looking for when they talk about wet labs versus dry labs versus other types of space. And Kay very graciously volunteered to provide that background information for our group. So we're really excited. We've got a good number of folks on the call today. I know there are a handful of others who wanted to be here but had a scheduling conflict, so we will make this available to them afterwards. So with that, this probably won't run a full hour, but if you have questions along the way, please let us know. Kay, I will let you, I'll manage it, monitor the chat box down below, but if you have questions, I'll let Kay handle that as we go. So Kay, with that, I am going to turn it over to you to do your thing. So thank you. Here we go.
All right. Well, thank you, Kristen. I really appreciate that. As Kristen said, I'm Kay Townsend. I'm a principal in our discovery market at BSA LifeStructures. BSA is about a 45-year-old architecture and engineering firm here in Indianapolis, and we specialize in several markets. The discovery market, or the science and technology, happens to be where I fall, and I've been doing that most of my career, and we do higher education as well as healthcare. So with that, Kristen and I think at one of our board meetings, we're talking about how do you talk with your clients and understand what they might need in laboratory space. So that's how this sort of came to be. So this is a very high level overview of laboratories. From the perspective of design, and really doesn't go into depth into the science. As you can probably surmise from my image, I'm going to keep this a little bit light. So for those of you that might be familiar with laboratory design, this will be a refresher course maybe, but I hope you hear something that you might not have known. And for those of you who don't know laboratories and laboratory designs, I leave you with a greater confidence to be able to speak lab, as I say, with your clients and know what questions you should be asking them when discussing their laboratory needs and how to guide them to a space that is maybe more appropriate for their lab. I guess over the last 24 years of doing this, I realized that when you do something for so long, it's hard to kind of condense this down into very basics. So if I confuse you on anything or use terminology that you do not understand, please put it in the chat and we will review that. We'll cover some basic terminology that you'll see associated with labs. We'll discuss at a broad level some of the various types of laboratory spaces that you might see your clients need. We'll discuss the complexities associated with laboratories, and we'll give you an understanding of why not all spaces really should be lab spaces. And finally, we'll discuss some of the trends and best practices of lab design. So I think one of the basic criteria of talking with clients and others about laboratory spaces is really getting familiar with some of the terminology associated with laboratories. And this list is just a small fraction of the terms you might actually hear when discussing these space needs, but it includes some of the types of spaces they might be needing. So for example, you might have a growth room for plant sciences, which is basically a controlled environment space for growing plants. You might have a dry lab for analytics or a wet lab for bioengineering, or you might hear them mention the type of equipment that they might need to integrate into their space. All of that will help dictate what they really need. So for example, they might be doing microscopy. Sounds very simple, microscope space. So they might need a wet lab associated with their microscopy activities, and then a dark room or a room that can be darkened for their spaces. Or they might be using a TEM, which is a transmission electron microscope, or a cryo-TEM. Those come with a whole different set of design criteria that you would need to consider when integrating that into their space. I like to become familiar with how they work in a lab. I like to go in and question the staff and ask them what they're doing, how they do it, and just see how they work. So I can help them determine if, we can develop a new, more efficient laboratory space for them. So in essence, what is a laboratory? Well, as you can see, Wikipedia describes it as a facility that provides controlled conditions in which scientific or technological research, experiments, and measurement may be performed. I kind of like to think of simplifying that into the basics, though. It's where a science type, a specific task is being performed. The physical space is typically dictated by the science of the space, and then the equipment that is required for that space can also inform how the mechanical, electrical, and plumbing systems need to be configured for that space. So as I said, I've been doing this for a long time, and I kind of ask a lot of these questions just intuitively, but I was thinking of how to simplify this for you all to talk to clients about their spaces. So I kind of broke it down into the science types to find out what they're doing: analytics, chemistry, or life sciences. Talk to them about their physical space, the constraints. We'll get into the clean rooms and biocontainment, talk about utilities and the equipment that they might be using. Some of them have very large pieces of equipment that will dictate what the space might want to be. So in talking with them about their science, find out, this is a list really of just some real basic types of lab spaces. They might align into an analytical or quality lab, QC lab, biosafety. We'll talk a little bit more. Can be on a college campus, in private. I'm going to actually, Kristen, take my video off because.
Yeah, you're cutting in and out a little bit there. Do we still have you? Oh dear. Well, hang tight, everybody. Hopefully we can get her back here. It looks like she's maybe logging out and having to log back in. So we'll just give her a second. I suppose one of the drawbacks to Zoom is when you lose a speaker, you can't just drag them back on stage exactly. So.
Hey, Kristen, while we're waiting, I mean, yep. Is there any early indications you can give us on kind of the survey, some of the lab surveys you've been getting? Is just kind of a curious peek at that, maybe?
Yeah, I'll tell you, the response has not been overwhelming in that case, but we have been able to dig up quite a bit of data, publicly available data on things like animal facilities, some of the other, any space that needs to be certified or carry some kind of certification. There is usually some kind of associated list. So we're going through and tying all of that information into our company database, our statewide company database. And I think when we get through with that process, we've got a couple more lists to kind of run through, but as soon as we get through with that process, I think we're going to have enough information to at least do an initial white paper on kind of what's out there and what our challenges might be. There are a couple other states I've heard about that are developing some really nice incentive programs that we can talk about in there as well. So it's a start of a process, and hopefully the next go around we do with it, we can just continue to expand on it from there. But stay tuned. There'll be more coming probably before the end of the year on that.
Thank you.
Yep. Okay, you make it back?
I think I made it back.
Yay.
So sorry.
That's okay.
I have no idea what just happened there, but that is our Zoom world, isn't it?
Yep.
Okay, so anyway, where I was, and I apologize for that, is talking about how labs can fall into some of these basic different types of lab types. So I had mentioned biologicals. Typically, labs will align into a BSL or a biosafety level. That is based on the biocontainment precautions required to isolate those agents and protect the people and the community around. You can see in the graph to the right that starts at BSL 1 and then goes all the way up to BSL 4. BSL 2 and 3 are really the most popular types of labs that you will see. 2 really is the most popular, that or most common, and that is the one that we design most often. Each one of these builds on a operating procedure, an SOP, and the personal protection equipment that is required. So BSL 1 typically doesn't require much. They're doing a little bit of benchtop work. They don't need a lab coat. They don't use safety goggles. It can be done pretty much in any type of space because of what they're doing. Then you graduate kind of to a BSL 2. It's a moderate risk. It adds the PPE. You add your lab coat. You add your safety goggles. It also limits access to the lab, so you're going to need to separate your offices and your lab space. Requires self-closing doors. You see the hand sinks, the emergency showers, and such. This is also where the labs are way different than an office in that BSL2 labs are 100% exhausted air. That's also why your labs are way more expensive space to design than an office space. When you jump to the BSL3 spaces, this is your high risk spaces. This is where you have serious or potentially lethal diseases, TB, Ebola, things like that, that need specific containment. Access to the lab is restricted and controlled. You enter through an anteroom, through self-closing and locking doors. You know, they have the full bunny suits, if you've heard that term before, you know, the shoe covers, the gowns, the face covers, everything. So those are less common. And you also, this gets to be more expensive space as well because you have a dedicated air handler system and exhaust system with a BSL3 lab. Even if you have it associated with the BSL2 space, they still have dedicated systems. You don't want any of that cross-contamination. Then you get into clean room spaces. These have really evolved. You can see the little graph on the right. People now call them ISO rooms. They used to call them clean class like 100,000 or 10,000. So this is measuring the particles of pollutants that are in the air, the dust and airborne particles, and they're controlled through filtration methods. So the cleanliness level is determined by the number of particles per cubic meter. So if you're getting into electronics or something like that, you will probably go down to an ISO 3 or an ISO 4 in order to produce that type of product. Clean rooms utilize what we call Hepa filters, which are high efficiency particulate air filters in order to capture all of those particles. You might also hear the term or hear your client say a MERV filter. That's a minimum efficiency reporting value in a filter, but it's really just a big complex type of filter that filters the air before it gets into the room. This is just a list of some of the basic types of labs of spaces you might see associated with laboratories. The science will typically inform all of the different types of spaces that they might need. I think earlier I mentioned like analytics, they might need only a dry lab space for all their computing. They might need a substantial IT closet for all their servers. because they're really crunching a lot of data and they're running a lot of data across the line. So they need their own independent servers. A wet lab would probably have the lab itself. It might have a tissue culture room for preparing samples, might need a walk-in cold room to store those samples. So understanding their science and what they're doing in there will help inform the types of spaces that you really are going to need to provide for that client. This, oops, fast fingers. This is just some images of some of the spaces that we've done to kind of give you an idea of the actual physical space that might be required. Number one is at Children's Mercy Research Institute in Kansas City. That's an equipment alcove corridor. And you can see a bunch of -80 freezers to the right and other refrigeration to the left. And as you can see, it really takes a lot of width in order to provide the adequate space to maneuver this equipment and to access the equipment. And it's also nice to put large equipment like this in an individual area so that you can kind of collect all the heat that this equipment generates. So it's always kind of nice to have that in one location. The engineers kind of appreciate that. Number two is a large diagnostics lab in Tennessee, where they basically just fill a space with different types of automation, and the users just kind of move up and down throughout the aisles, loading the samples. Very heat intensive and also very power intensive. Number three is actually a teaching lab at Butler University. And what you see to the right is a fume hood, which is basically a chemical capture hood to protect the users. And most of the fume hoods are ducted, so they will require exhaust fans on the roof. But at this application at Butler, they didn't have the ability to provide all the ductwork required for fume hoods. So these are the Erlab filtered fume hoods. I believe we have like 18 of them installed at this site. Filtered fume hoods are not appropriate for every type of chemistry, but the vendor can provide, if you provide the vendor with a list of the chemicals that you will be using or your client will be using, they can tell you whether you could use the filtered fume hoods. Number four is a cryo-TEM at Purdue University. And these really, they look kind of like a simple piece of equipment, but they have a lot of building criteria that come along with them. You know, it's not only how you get this large scope into the room, which we actually had to do a knockout panel on the side of the building to get the scope in, but it's got a lot of associated equipment. It's got a chiller on the side and liquid nitrogen, very heavy. So there's a lot of building criteria that you have to evaluate when thinking of installing a piece of equipment like that. The last image is from WashU, and it is showing a holding room for fish. And so these spaces have specific water requirements. They also have some loading requirements. As you can imagine, all of those racks with all the fish tanks could get very heavy. And obviously there's a trench drain down through the middle. So you have to be able to see if your space could support providing a drain for such a facility. So, and as a recap, so how do we talk to our clients? You know, really identify the space and what they're doing in that space. Identify if they need biosafety level containment or a clean room space. Identify the large pieces of equipment that they might be needing to help determine the mechanical, electrical, and plumbing needs they have, and then identify all of the support spaces that they will need. So in understanding the lab design, is kind of important to understand the basic geometry. We like to think of them as lab modules or lab bays. As you can see to the diagram to the right, you know, there's a 20-foot module, which we call a full module, or a half module, which is 10 foot wide. We really base those on the way a lab functions. You know, you've got your wall benches at about 30 inches. You've got your island or your peninsula that's typically about 5 feet wide. And then good lab practice is for 5-foot aisleways. So when you think of these as building blocks, box. If you're looking at a very large lab space, you can sort of look at these lab modules and just stack them as in the colored diagram below, in various ways to provide the types of space that the users might need. You can see the blue is the laboratory space. It can be broken down into laboratory support space or offices and everything. And this module works very well for overall building design. So not all spaces are created equal for lab use. This slide really could be an entire presentation all on its own, just about codes and guidelines and ordinances and authorities having jurisdiction, but I will not put you through that. I would not want to sit through that. I just wanted to kind of show you all of the different codes and guidelines that we as designers take into account when creating or recommending a space for a client. Pretty extensive. Not all buildings have key attributes to be a lab, not to mention all of the codes and everything, but the buildings themselves. Dimensionally, horizontally, we like to see the lab bays, the way the columns are laid out in the building. Vertically, as you can see by the image, this is actually, a basement space, but you can see all of these are transfer gear for electrical, but you can see all of the items that are required and how they come up and above and go above the ceiling, to support the lab functions. So typically an office building, you're going to see maybe a 10 or 11 foot floor to floor height. Labs, we love to have 14 and 16 feet if we can. So not every building can provide the above ceiling space needed to support lab functions. Structurally, labs are typically designed at about 150 pounds per square foot. We'll see offices that are at about 100. I have a project right now in LA that it is an office building that we are putting a lab in, and we're having to go back and reinforce the floor in certain locations for their archives room or heavy equipment. So that's always a cost that, your clients may not want to absorb. Fireproofing, depending on the chemical uses that your client might have, that we may need a 2-hour separation or 2-hour assembly for them. Most of your office buildings don't have adequate loading docks for materials and for bringing in heavy equipment, or a service elevator that you could put a biosafety cabinet in and take up the floor, or to bring in a pallet of product reagents or something. So that's always something to keep in mind. As far as energy control, office buildings are usually recirculated. Now with COVID, we have seen them want to provide fresh air, but typically offices are recirculating supply and exhaust on their air, and labs are 100% exhausted systems. So if you're putting a lab into an office building, you may have to provide, or very likely will have to provide, a new air handling system for the building. Electricity, labs require tons of power. Most office buildings do not have service entries quite that large for the buildings, so you'd probably have to put in a new electrical service. They most likely will never have an emergency generator, and most labs will require emergency power. So that's always about a $500,000 cost that you might add to a project in order to provide emergency generator and emergency power to a lab space. And as I mentioned, the labs have an intense demand for ventilation power and also plumb services that office buildings do not typically have. So going to some of the best practices and trends that we see in lab design, as I mentioned, utilizing the lab module and open concept lab when possible. This really provides the most flexibility for future if your client moves out or they have a new science or a new process. It is the easiest to adapt and modify. Today's science is very social. Collaboration, that's one of the buzzwords of today, collaboration. And so having a more open lab space creates and fosters collaboration. As I mentioned, designed for future flexibility and adaptability. You can kind of see from this image, the way labs used to be back in really the 60s and 70s and 80s. You had all the fixed casework, your fixed mechanical systems. We started seeing a little bit more flexibility come into that, to where we have adapted pretty much to today to overhead services and mobile benching, especially in the middle of a lab. And you will maybe provide some of the fixed benching in your water and sinks at the perimeter, but keeping the middle of the lab open for future flexibility and adaptation for science. I always like to think about designing for sustainability. That sustainability can be operational sustainability for like maybe utility costs. A lab consumes 5 to 10 times more energy per square foot than office buildings. And specialty labs, such as a clean room, can consume up to 100 times power and energy than a similar size commercial building. So that's always something to keep into account. So determining the correct mechanical systems can make a huge difference in operational efficiency. Sustainability can also be applied to staff efficiency and productivity. One of the least efficient things, I don't know if you guys know this or not, in a lab is the human. So providing daylight can increase your staff's efficiency and productivity. And again, that's a whole other presentation that we could get into. By providing daylight, though, you really can increase the staff efficiency and productivity. It's statistically or scientifically proven that in biophilia. I know I just spent 2 weeks in the sunshine and I feel much better and more productive. So I guess that was my little scientific experiment. As always with lab design, it's safety first. You have to consider the chemicals being used, the biosafety levels that they need, the fire hazards. While it's rare, there have been fume hoods that have exploded over the years because of the chemicals within the hood. So there's always those considerations. Life safety, providing all of the emergency showers, the hand washing, and always keeping in mind any kind of the bloodborne pathogens that might be in the air. And as I mentioned, maximizing the daylight, it not only is staff efficiency and productivity, it really can reduce your operating costs. And costs are something that I've kind of mentioned, but kind of flown over a little bit in that per JLL, as you can see, there's a large variation of lab construction costs compared to office costs. And right now we are seeing a huge upswing in construction costs. They can recommend from $350 to $1,325 per square foot. Obviously, a standard biosafety level 2 lab will run in the $350 to $450 range. You get into your clean room spaces or your BSL 3 spaces, and you're going to see that in that upper range. There really is no good formula to give for, this is exactly how much your lab will cost, because it is sort of a tailored process for each science and their processes and their requirements. So what can you do to assist your client to find or develop a lab space? Understand what it is they need to operate efficiency, and that understand that available space doesn't always mean good lab space. Help them understand the complexities and the costs that could be associated if they want to adapt a non-lab building to support their lab functions, and know that costs are currently all over the board, experiencing extreme fluctuations and have jumped significantly. So basically being a realist. I just told a client in a meeting this morning that I like to be transparent and I like to be real, and labs are not cheap spaces to develop and build. And I think the client and the users need to be aware of that. Here are just some resources that we will share with you if you want to delve way deeper into all of this. This biosafety and microbiological and biomedical laboratories that we easily call BMBL instead, is just a great guideline to help guide you if you have questions on how to deal with pathogens. The NIH has some great information online. CIFA does, CDC. So there's just a wealth of information out there that can help you understand laboratory design just a little bit more. That's a brief highlight. I like I said, I've been doing this so long, I kept getting in the weeds about what information to present to you. I wanted to keep it very high level, and I hope that you got something out of this that you can help that can help you talk to your clients a little bit better in the future about the spaces that they might need.
Well, there we go. Thank you so much, Kay. We had a great question. It looks like we maybe have another one in here from Sally Clark, who is asking about saying she's not seen a lot of requests for environmentally friendly or energy efficient labs for federal clients. But if there's more interest in some of the green lab initiatives and the environmentally friendly lab stuff, which is something that Kay and I have actually been talking a little bit about recently. And I just got off a phone call with my counterpart in Scotland where we were talking about just that and some of the environmental regulations that are coming in. So if you have, Kay, would you like to touch on that real quickly?
Sure. Well, most of the, wherever you are designing a facility, so for example, in Indiana, you have your energy codes, which follow ASHRAE 90.1, which does provide a certain level of sustainability for clients. You have all of the different initiatives from the AIA and different groups that are trying to green up lab spaces as well. There are various ways that you can provide sustainability without adding a lot of cost for labs. I was thinking that we do not do a lot of federal work, but I was thinking that a lot of them are requiring a certain level of sustainability. ASHRAE 90.1 provides a pretty good level of sustainability just in itself to meet that energy code. There are various ways that clients, users can do some sustainability techniques without, going through the building facilities, providing newer -80 freezers that operate more efficiently, being green in their chemical usage and things like that. There are green labs groups that are out there that can help guide you towards more sustainability. I2SL, their website offers a variety of sustainability techniques to implement in a facility as well. I'm not sure if I quite answered all of that, but sustainability is heavy on the horizon with lab buildings being so such energy hogs.
Sally, if that answered your question, or if you'd like to turn your mic on, you should be able to do that. And if you'd like to ask any more to that.
That's a good answer. I guess I was asking more so for the commercial space. Since we are, the federal side's pretty much not doing anything except for following the code. Is there anything sort of pushing the boundaries on the commercial side? Because what we found is that federal is just, it's a lot easier for them to follow what is happening in the commercial side than for them to be on the cutting edge themselves. They just play it too safe.
Yeah. I think on the commercial side, it's educating really the clients and the owners, as to the benefits of that sustainability, showing them that return on their investment, because it is not a cheaper solution at the very beginning. There is your initial costs, but your operating costs down the road, they could really benefit from that. So I think it's sort of a conversation with them at the beginning, showing them the benefits of a sustainability strategy. There are some developers and some clients that just don't care, unfortunately. And so I think it's our job as designers to help try and educate them.
Great, thank you.
We have one other quick question here. For given the specialty nature and cost of building labs, are most owned by the company or leased in your experience? Kay?
I am seeing that both ways. As a matter of fact, I have a national client that does both. They own some and they lease some. I think the leasing strategy is always a bit sticky in that sometimes they will try and lease a space. As I mentioned, not all spaces are good lab spaces. And so it would be good if they could bring you in at the beginning to help evaluate that space and not just say, this is a space that we'd like to lease, make it work. But you do see both. You also see companies out there, incubators, that you go in and lease your space, you share your core services like you would share a fume hood alcove, a microscopy suite. You might rent out just a small wet lab to do your processes. So there's all kinds of financial incentives for doing that. Something that Kristen and I are also working on because Indianapolis and Indiana does not have a ton of available lab space, but incubators would be one of those where you lease a certain amount of space.
That's great. Do we have any other questions? Okay, if not, well, we'll say thank you very much for your time today. Kay, thank you. That was a great presentation and one I'm sure we will be drawing on as a resource for our folks going forward for quite some time here. So we appreciate it. With that, we'll just turn everybody to give you the rest of your hour back and have a great afternoon. And thank you again. We'll have another business development forum program coming up here soon, and we'll let you know when we have that all sorted out. So thank you very much. Have a great day.
Thank you.
Thanks, everybody. Bye.